Okay, the next step of solving linear systems or linear equations is with fractions. So we looked at that at the very end of the last lesson. Let's look at it here. We have p minus 2/5 equals -4. Really remember that p is really a fraction. That's like p over 1. And -4 is really the fraction -4 over 1. Just for our mind space right now. So, depending on how you were taught, you'll be thinking we need to get one fraction, like we did in the previous lesson, on the left, one on the right, and then we can cross multiply, meaning multiply across the equal sign. Bottom of the left times top of the right, bottom of the right times top of the left. So we need to get this to be one fraction. To add or subtract fractions, we need a common denominator. So p over 1, what is it in terms of 5? So to get that, we'll say like the bottom times 5, but because we've increased the bottom 5 times, then we want to increase the top 5 times. So 5 times p is 5p. 5 times 1 is 5. And we're going to subtract 2 over 5. And all of that is equal to -4 over 1. Now that we have a common denominator, we can add or subtract the top. So -5p take away 2 remains like that. They're not like terms, so we can't take away 2 from 5p. Like we did previous, we're going to take the bottom of the right, we're going to multiply it times the top of the left. So we're going to distribute. So that's 1 times all of 5p minus 2. Then we're going to take the bottom of the left and multiply it by the entire top of the right. So 5 times all of -4. Remember that we need to distribute in. Luckily this is a 1. So it's fairly straightforward. 1 times 5p is 5p. 1 times -2 is -2. 5 times -4 is -20. We got rid of fractions. We're not afraid of them, but all we've done is we've made the same numbers bigger so we can talk about it in terms of full numbers. All the terms with p are on the left, so let's get all the constants on the right. Add 2 to the left, add 2 to the right. Divided by 5, divided by 5, and we have p equals -18 fifths. So the question had a fraction, our solution is a fraction. That is okay. We were to put that in a calculator, divided by 5 is going to give us a nice number, or a nice decimal that doesn't go on forever. So that is the same thing as -3.6. Not wrong to put it as a decimal, but don't be afraid of fractions. Now I'm going to use this one as an example. Depending on how you've been taught, something that you might gravitate to and find somewhat easier. Skip a few steps. Is find the common denominator. So if we look at all the fractions in the original question, we have 1, 5, and 1. We need a common denominator. Number that 1 and 5 and 1 all go into, and that number is 5. So if I take that question, I'm going to just rewrite it. What I'm going to do is I'm going to multiply the entire equation by 5. That means that times 5, that times 5, and that times 5. And 5 times p is 5p. And that negative is there, so don't forget the negative. So there's a negative. 5 times 2 is 10, divided by 5 is 2. Or 5 divided by 5 is 1, and 1 times 2 is 2. The equal sign stays where it is. And negative 5 times 4 is negative 20. And look at that. Using a common denominator, I didn't have to get one fraction on the left, one fraction on the right, and then cross multiply. I'd get right to that step, and now it's a two-step equation that I can solve for my unknown the exact same way. This might be more handy when every one of these is a fraction, every term is a fraction. So let's see. This is the way I prefer it. There's nothing wrong with this, but again, math, different paths can still lead to the same answer. One is not incorrect. Just I always look at what's the least amount of steps I need to show. So common denominator, there it is, reduce any fractions, multiply them through, there. So if we apply that for question B, we have a fraction 2 and 5 and 1. Well, 1 goes into everything, so we need a number that 2 and 5 both go into. Sometimes we want the smallest one. If we're not sure, 2 times 5 is 10, so I'm going to multiply everything by 10. That means this fraction gets multiplied by 10, this fraction gets multiplied by 10, and that number gets multiplied by 10, or that fraction gets multiplied by 10. See, this time I put the negative 3 in brackets, that's okay. That's not exponent 10, that's times 10. So 10 times x divided by 2 is the same as 10 divided by 2, which is 5 times x, 5x. There's a plus sign. 10 times 2x, 20x, divided by 5 is 4x. Or 10 divided by 5 is 2. 2 times 2x is 4x. Whoa, so I can do that. And then 5 times x. 10 divided by 5 is 2. 2 times 2x. Not a fraction, so I just multiply it. 10 times negative 3, negative 30. Fractions are gone in one step once I'm more comfortable with my mental math. Like terms, add them together. Solve for the unknown. Negative 30 over 9. Final answer, done. Although, we're not afraid of fractions, and can I reduce? Well, even and odd, but you might know something about number 30 and 9, so try 1, try 2, oh, can't divide each by 2, try 3, oh, hey, I can divide each of these by 3. Always reduce our fractions. Negative 30 divided by 3, negative 10, and 9 divided by 3. Just reduce to the lowest terms possible. Okay. There's nothing wrong with getting one fraction and cross multiplying. Flip the page, I'll do the last example, and I'll do it both ways.